Okay, chapter 1, section 2, talking about angle relationships and similar triangles. Vertical angles have equal measures. So in geometry, I hope that you have seen two parallel lines cut by a transversal. You have alternate interior angles. So you have them on the interior. One's on the interior of the parallel lines, one's on the opposite. So they are on opposite sides of that transversal line. Also, angles 3 and angle 6 would be alternate interior angles as well. The angle measures are equal. Alternate exterior angles. That means they're on the outside of the parallel lines. They alternate on opposite sides of that transversal. The angles are equal. Interior angles on the same side of the transversal, so same side interior. They add up to 180. So 180 degrees because they form that straight line. And then you have corresponding angles, which are on the same side of the transversal line, but they, if you look here, 2 and 6 are on top of those parallel lines, so they're corresponding, and they are equal. And vertical angles are the ones that make the V's. So if you had two parallel lines cut by a transversal, this and this are vertical angles, so you got a V here and a V there. Same thing here, vertical angles. And they are equal. Example 1. Find the measures of angles 1, 2, 3, and 4 in the figure, given that lines M and N are parallel. Okay, so we have angles 1 and 4 are given to us in X values, or in expression form, and we can tell that angles 1 and 4 are alternate exterior angles. So on the outside, they alternate sides of that transversal. So alternate exterior angles are equal to each other. So we would say 3x plus 2 equals 5x minus 40. Going ahead and putting my x's on one side. 2 equals 2x minus 40. Adding 40 to both sides. 42 equals 2x. Dividing by 2. 21 is going to equal x. So that is not the measure of my angle. That is just the value of x. I am then going to plug that back in and find, so I'll take 3 times 21 plus 2. And since they're equal, I really only have to do this once if I did my math correctly. 3 times 21 is 63 plus 2, which will give me 65 degrees. So the measure of angle 1 equals 65 degrees. The measure of angle 4 equals 65 degrees because those are equal. Now, angle 1 and angle 2 form that straight line. So that means they're going to add to 180. So in order to find the measure of angle 2, I'm going to have to take 180 minus 65, and that'll give me 115 degrees. So the measure of angle 2 is 115. And then the measure of angle 3 is a vertical angle to angle 1. So the measure of angle 3 is also going to be 65 degrees because vertical angles are equal. For triangles, angle sum of a triangle. The sum of the measures of the angles of any triangle is 180 degrees. If we look at example 2, applying this angle sum of a triangle property, the measure of two of the angles of a triangle are 48 degrees and 61 degrees. Find the measure of the third angle, x. So we know that all three angles have to equal 180. So I'm going to say 48 plus 61 plus x is going to equal 180 degrees. So this is going to give me 109 plus x equals 180. Subtracting 109. We get x equals 71 degrees. Can the angles of a triangle be 60 degrees, 70 degrees, and 80 degrees? If you go to add all those up, 60 plus 70 plus 80, your answer is going to be greater than 60 plus 70, that's already 130 degrees, and another 80. Your answer is going to be greater than 180 degrees. So no, because the total degrees of the three angles is greater than 180 degrees. So definitely not. Those cannot be the measures, angle measures of a triangle. There are different types of triangles. So if you have all acute angles, meaning that all your angles are less than 90 degrees, you have an acute triangle. If you have one right angle, you have a right triangle. And if you have one obtuse angle, meaning that the angle is greater than 90 degrees, you have an obtuse triangle. If all sides are equal, you're going to have an equilateral triangle. If you have two sides equal and the third side is not, that is an isosceles triangle. And then if none of the sides are equal, that will be a scalene. Conditions for similar triangles. Triangle ABC is similar to triangle DEF if the following conditions hold. Your corresponding angles have to have the same measure. So angle A has to equal angle A. Your corresponding sides are proportional. That is, the ratios of their corresponding sides are equal. If two triangles are congruent, must they be similar? And if two triangles are similar, must they be congruent? That reflect question we're not going to worry about. Example 3, finding the angle measures in similar triangles. So if you look here, angle A has one little half moon, so does angle N. So that means that those two angles are equal. So angle A is 45 degrees, angle N is 45 degrees. Angle C has two half moons, and so does angle P. You are told that the measure of angle P is 104 degrees. So that means the measure of angle C equals 104 degrees because it is congruent with angle P. Angle B and angle M are going to be congruent. They have three little half moons. So in order for them to have the same angle measure, we're going to have to say 104 plus 45 plus x equals 180. We're going to have 149 plus x equals 180. And when we subtract that, we're going to have x equals 31 degrees. So the measure of angle B and the measure of angle M is 31 degrees. Angle C was 104. Example 4. Given that triangle ABC and triangle DFE in the figure are similar, find the lengths of the unknown sides of the triangle DFE. So since they're similar, their sides are going to be proportional. So if we look here, side AC is going to be proportional to side DE. Side AC is 16, side DE is 8. So that means they have a portion of 2. So in order to find the next one, let's say we want to find side DF, we're going to say 8 over 16. Whichever triangle you use first, you're going to say two sides are proportional. And whichever one you use in your numerator, make sure you do the same when you're looking for that side. So since I used the smaller triangle in my numerator, I'm going to set up a proportion. I'm going to say, that was DF. DF over 24 in order to find the measure of DF. So again, side DE is proportional to side AC. So I took DE and put that in my numerator and took AC and put that in the denominator of a fraction. A proportion is pretty much a ratio. I'm going to solve this proportion, so I'm going to set it equal, and I'm going to say side DF is going to be proportional to side AB. Another way you can tell that they are proportional is by going off these half moons and the angles. So DE, D has a single half moon, E has two half moons. It's proportional to AC. A has the single half moon, C has the two half moons. So in order to solve, we're going to cross multiply. Anytime you set two ratios equal to each other, you cross multiply to solve. So we're going to say 8 times 24 equals 16 times DF. 192 is going to equal 16 DF. And I'm going to divide both sides by 16. So 192 divided by 16, side DF is going to equal 12. So now I want to do the same thing. Side BC is going to be proportional to side FE. So again, smaller triangle. I'm going to say FE over 32 is going to be equal to 8 over 16. And with any type of problem like this, anytime they give you information, always use the information given. Because if you made a mistake here and you said 12 over 24, and you use that information, then your second part of your answer is going to be wrong, and that'd make the whole problem wrong. At least if you made a mistake here but used your information given, I'll be able to give you partial credit on a test. So this will be 16 FE equals 8 times 32. 16 FE is going to equal 256. Dividing both sides by 16, FE is going to equal 16. Okay. So those are the measures of your two missing sides in angles DFE. Or your two missing sides. Last example is example 5. Finding the height of the flagpole. Workers must measure the height of a building flagpole. They find that at the instant when the shadow of the building is 18 meters long, the shadow of the flagpole is 27 meters long. The building is 10 meters high. Find the height of the flagpole. So I'm going to say I have a building, and it's casting a shadow, and it's going to make a right triangle. The building's going to meet the ground. It's going to have a right triangle. I also have a flagpole. Again, remember, guys, I did not go to school for art. Okay, that flagpole is casting a shadow. And we're going to have another right triangle where the flagpole meets the ground. So look back at your word problem. They find at the instant when the shadow of the building is 18 meters long, the shadow of the flagpole is 27 meters long. The building is 10 meters high. We need to find the height of the building. So again, we can set up a proportion in order to solve this. I'm going to say X, the height of the flagpole, over 10, the height of the building, is going to equal 27, because that's the same triangle, over 18. So I have 18x equals 270. And with that, x is going to equal 15. So the height of the flagpole will be 15 meters. Your homework for this section is posted on the agenda. If you have any questions, don't hesitate to message me.